Welcome to my video lecture. Today we are going to see about Taguchi loss function. So who is Taguchi? Taguchi is a Japanese statistics person, and not only that, he is a quality engineer. He combined the quality and statistics to find some new things. That's what called Taguchi loss function. Before we are going to see about Taguchi loss function, we will see something about quality. You see here, the quality is the conformance to specifications. This definition was given. This is given by Zuran in 1974. And then the approval for this quality is conformance to specification given by American Society for Quality Control in 1983. And also Mr. Zuran observed that quality is fitness for use. The American Society of Quality Control defined quality as the totality of features and characteristics of a product or service that bear on its ability to satisfy given needs. So what's the meaning of this? When you are going to find a product or when you are going to buy a product, what will happen? Normally, the working range or output range or input range, they will give one target function. For example, when we are going to give input for some electrical items, that one, it will be normally 230 volt, but input they will give plus or minus 20 volt, or plus or minus 25 volt, plus or minus 30 volt. So that working range they will give, or the input range they will give. The same manner, when you are going to have some output from a product, that output, it's having some target. For example, when you are going to pump water using some water pump, that water pump is delivering some 100 liter per second means you can change 100 plus or minus 20. So like that only normally manufacturer will give. Why they are giving this kind of ranges? Because the manufacturers are not sure about the exact target. But what Taguchi loss function is saying, you see here, this one is the target. For example, when you are going to buy a pump, 100 liters per minute, something if it is giving. So this one is the 100 liter plus or minus 20 liter it will give, you assume. When you are going for traditional approach, if it is going, so this is the target, assume this is the target, this is the 100 liter, plus or minus 20, suppose if it is going 120 or if it is coming 80, it is under control. Normally this is the traditional approach. If it is going beyond this limit, then you can say there is a loss. If it is going beyond, less than this level, you can say this is the loss. But what Taguchi is telling, even if it is 105 or 95, so both the things it will give loss. Less than the target, definitely it will give loss to the company or loss to the society. This is what Taguchi is saying. So Taguchi loss function, how can we define L of s equal to k into x minus t whole square? So what is L of x? L of x is the last calculation function. K is constant. What is x minus t? It is called tolerance value. What tolerance value you are going to give from the target? So this is what we are going to see. See, the next slide is saying traditional methodology and Taguchi methodology. So this is what I explained in the board. You see here, this is the value of characteristic and there will be a target, and then after some time it will give loss. Less than the target value it will give loss. But when you are going for Taguchi, instead of this kind of curve, he has given bowl shaped curve. Why bowl shaped curve? You see here, this is the lowest specification limit. This is the upper specification limit. Even in between that also there will be a loss. When you are going for the traditional method, in between there you are considering as it's okay, there is no loss. But actually when you are going, even you see here, the target is 100 means 95 if it is coming, or 105, even 101 if it is coming, it is called as a loss function. So this is what we are going to calculate, how much the loss will incur when you are going to deviate from the target. This is what Taguchi found. Okay, so you will see here the traditional methodology. So there is one example. Coke can filling station. See, you have to fill in the Coke can 330 ml. What is the upper specification limit? Company has given 340 is the upper specification limit. Lower specification limit is what? 320 ml is the lower specification limit. If it is going 340, if it is coming 320, then it is good. So we are not going to face any loss. This is what the traditional method. But when you are going for Taguchi, it's a bowl shape. Even if it is going 1 ml extra, or if it is coming less than that, what will happen? If it is going more extra, it will be the loss to the company. If it is going less, then it is loss to the consumer. So this is what. So there will be a chance of coming loss to the customer, and also there will be a chance for the loss to the company. So this is what it is given. Taguchi methodology, what it indicates that there is a losses associated with the product if the product is not on target. The exact target your product is not achieving, definitely there will be some loss. This is what Taguchi is saying. See, less targeted quality. So what that kind of product we are saying? Less targeted quality product. Loss your product causes to society after being shipped, other than losses caused by its intrinsic functions. So what it means? Suppose you are going to produce one product in a company. When you are going to give more than the targeted value, then company will face some loss. After shipping, so once you have shipped, suppose the targeted you haven't achieved. When consumer is going to consume this one, when he is going to buy, by the time he is investing, whatever the consumer expectation, if it is not satisfying, whatever the target, if it is not satisfying, then what will happen? The consumer will face automatically some loss. So this is what. So there will be a loss for the consumer, there will be a loss for the company. All those things you can find out how much the loss using Taguchi loss function in a statistical based. Normally quality we are telling that it has to satisfy the customer requirement, and then the quality products, it has to confirm the specification. So there are many definitions given by different societies, given by different quality gurus. But here, Taguchi, what he is saying, it is possible to calculate the loss in a statistical manner. So this is what Taguchi found. Okay. So you see here Taguchi methodology. So there are two categories: loss caused by variability of functions, loss caused by harmful side effect. Taguchi is saying that a product or service has good quality if it performance its intended function without variability. Even 1% there is a variation and there will be a loss, and causes little loss through harmful side effects, including the cost of using it. So this is what Taguchi is saying. See, Taguchi loss function, as I explained already. So this is the targeted value, and then this is the lower specification limit, and this is the upper specification limit. Even in between that, normally what is called a traditional method will not calculate. You see here the traditional method. In between that, we are not calculating loss. Here only after upper specification limit, after less than this lower specification limit only we are concentrating, but Taguchi is concentrating in between that also. See here, this is the target and lower specification limit. In between that also he is concentrating. See how to calculate the loss. You see here, L of x is equal to k into x minus q whole square. L of x means what? That is the loss to the society or loss to the company. So both it is possible to calculate. And see here, T equal to ideal state, that is the targeted value T. Target means what? See, 100 liter, it has to come from pump per minute means it has to come 100. That means target. For example, we are going to fill in a can 330 ml means you have to target 330 ml. So this is what target value. K is a constant, so we can say this is Taguchi constant. So this is what we are going to calculate. Then after that, for the further calculations, you can use this constant to find the loss value. See here, x is equal to quality characteristic. Quality characteristic means what here? See, the target value is 330 or 100 means how much the deviation? See, 105 is going. That 105 is called quality characteristic. So x minus t, when you are going to have 100 is the target, 103 is the quality characteristic, then 100 minus 103 minus 3. So this one will be the tolerance, you can say. See, x minus t, 100 and see, for example, t value, t equal to target value equal to 100 liter per second. Originally, how much I am getting? X is equal to 103 liter per second I am getting. So, x minus t, how can I calculate? 103 minus 100, then it will come 3 liter. Then after that you have to square, you have to multiply with Taguchi loss function, Taguchi constant, then to get the loss function. So this is what we are going to find using some example. See, now I am going to explain some example. Example number 1. What example number 1 is saying? The XYZ company manufactures step-up transformer. What step-up transformer will do? When you are going to give some amount of voltage, then it will step up and then it will give some amount of voltage. So, for example, 230 volt we are giving. So that is the normal domestic supply voltage. And when you are going to give 230 volt, and then if you want to step up, then you can step up into 300 volt, you can step up into 400 volts, so like that. So you can step up this voltage. See, the XYZ company manufactures step-up transformer which will give step up from 230 volt to 500 volt. So the output will be the 500 volt. So for a power supply whose output is 500 volt, the deviation, the allowable deviation is 25 volt. It is given. Any deviation of 25 volts or greater in the output will cause OMR 400 loss. See, the 25 volt they have given. If it is going more than 25 volt or if it is coming less than plus or minus, then there will be a chance of loss 400 real. Okay. If company adjusts the voltage in the factory by changing a high quality resistor which costs just only 1.50. So one resistor you are going to include inside there. If you are going to include, there will be a chance of arresting this loss, huge loss. That cost quality resistor when you are going to include in this 1.5 OMR only is coming. See, now what we are going to find, calculate the value of K in the Taguchi loss function, the tolerance value within which should the power supply units be manufactured with high quality resistor. If you are going to add the high quality resistor, then what will be the tolerance value? And the first one is what will be the value of the K in the Taguchi loss function. So how much the loss function is given? So this is the reason. So you can calculate what will be the K value. See how we are going to calculate. You see here the voltage specification is given 500 plus or minus 25 volt. This is what is given here. And then the scrap cost, when you are going to exceed this value, you will get the loss 400 OMR. Additional resistor cost, when I am going to include an additional resistor inside the product, I will get 1.50 OMR only extra. Okay. See, when I am going to have the first two data, then if I am going to calculate the K value, how much it's coming? L of x, that loss function and loss I am going to calculate K. Loss is given, 400 OMR is given, I am going to calculate the K value. That is the Taguchi loss constant value or Taguchi constant or constant. So all those things same only, K into x minus t whole square. So how much the x is 500 it is given. See here, the tolerance square, tolerance is 500. Suppose the maximum, if it is there, then 525. So either plus or minus. If it is less or high, it will come minus 25 or plus 25. When you are going to square, the same value will come, and here 400 will be there. 25 square, it will come approximately, I think, how much? 625. 25 into 25, it will come. Then 400 divided by 25 into 25, the here value it will come 0.64. So very easily you can calculate. See, L of x equal to k into x minus t whole square. K value I am going to find. X is 500. X is 500. Assume 525 minus the targeted value is 500 whole square. Then k 525 minus 500, it will come 25. The maximum value I am going to calculate. L of x already it is given as 400 OMR. And k into 25 multiplied 25 because it's square. So 400 divided by 25 multiplied 25 equal to k value. This is what it is coming as a 0.64. This is given here. So this is the Taguchi constant we have found. Okay. Now what is the next? It's given when you are going to include one resistor. By the time, what will happen? What will be the tolerance value will come? This is what they are questioning. So what will be the tolerance, maximum tolerance we can give? See, the 0.64 is the Taguchi loss function already we have calculated. Then 1.50 extra you are going to invest. This is what 1.50 is given. So loss for the company only 1.50 extra. So when you are going to give this one, then how much is the tolerance? Only 1.53 is coming. The tolerance square we are going to calculate. Then 2.34 if it is coming here. Then what is coming? Approximately 1.53 volts tolerance it is coming. So this is what. So when you are going to include this what is called one resistor, the power supply unit should be manufactured within a maximum tolerance value of 1.53 volt. If we are going to have this kind of tolerance value, then you can say you can minimize the loss for the company and also you can minimize the loss for the society. So both it is possible when you are going to find the Taguchi loss function according to the, if you are going to react in your company manufacturing, then you can reduce it. So there is a comparison between traditional methodology and Taguchi methodology is given. So already I explained. So the same thing is given here. So what is the deviation in traditional methodology and what will be the deviation in Taguchi methodology? Everything is given. Example number 2. See, there is only one value, using only one value we have analyzed in the first example. Here the set of values given. Set of value means there will be a target and we are going to have bunch of products. In that there will be a deviation. So we are taking that as a sample, and then after that, then how can we calculate the expected average loss per pump? So this is what the next example is. XYZ company manufactures a range of pumps, a different variety of pumps they are manufacturing for pumping waters. One of the models has an output flow rate 45 liters per minute. So this output is 45 liters per minute. If the flow rate varies by 3 liters, so there will be a chance of varying 3 liters. 3 liters that's given by manufacturer. That means there will be a chance of coming 48 maximum liters per minute, and there will be a chance of coming 42 liters per minute. So this is what the manufacturer has given some range, because they are not due to component quality, due to some input variation. So all those things it's possible. So all of the manufacturer used to give this kind of ranges. Okay, if the flow rate varies by 3 liters per minute, this results in an estimated cost loss of OMR 580 per year. Okay, so they have given how much is the loss when there is a variation. A sample of 20 pumps is taken. Okay, 20 pumps was drawn from the production line, and the following measurements in the table are found. Calculate the expected average loss per pump. Expected average loss. So they are not asking for the only one pump. They have given one set of pumps, and after that you have to find it out how much the average. Normally the company will try to find the average level of loss only. Okay. When there is a variation, then what will be the loss will come. See, there is a set of value 4, 4, 4, 4, 4. I think 1, 2, 3, 4, 5. 4, 5 into 4, nearly 20 it is there. After that, what you are going to do? You are going to take all of the values here. See here, 45.3, 44.7, 46.5. So these are all given. It's given here. So the same values it's given. See 45.3, 44.7, 46.5, 43.5. So these are all it's given. So the same thing we have tabulated here. This is we have taken as an X. So X means what? That is the quality characteristic. So this is what originally it's given by the pump. The targeted value is what? Targeted value is 45. 45 is the exact target value. When you are going to calculate this one, x minus t whole square L of x. See, when you are going to calculate the k value, L of x equal to k into x minus t whole square. So the k value I want to calculate, the x value will be there. See, originally the maximum they have given 3. So originally the target is 45. The maximum it is given as 48 whole square. L of x equal to how much the loss is given already. 580 is given. 580 OMR per year it is given. K into 3 square. So K equal to Taguchi loss constant equal to 580 divided by 9. How much it's coming? It is coming around 64.44. So this one is coming as 64.44. So 64.44 is the constant we have calculated according to the given information from the question. So now we have to fill the table. You see here, x minus t, I am going to calculate the second column. How I am filling? X is given value. X minus t, 45 minus 45.33. Or 45.3 minus 45.3 is coming. 44.7 minus 45 is coming minus 0.3. Plus value or minus value, you need not worry about that because Taguchi loss function is x minus t whole square. So when you are going to square this one, either plus or minus, it will come positively. So this is what the x minus t whole square is there in the Taguchi loss function. So you are going to find it out from the targeted value, and then after that you are going to square the function. So you are going to find it out. Okay, fine. Then after that, what you are going to calculate? K into x minus t whole square. K 64.44 already we have calculated based on the information which is given in the example. That means question. Then after that you are going to multiply the k with x minus t whole square. Then after that, how much it's coming? 2368.17. 2368.17. How we have calculated? See here, k into x minus t whole square. The loss I have calculated for the first pump, it's coming around 5.7 OMR, and the second one also it's coming 5.7 OMR. And when you are going for the third pump, 144.99 it is coming. And when you are going to calculate for all of the pumps, it's coming around 2368.17. So when you are going to average it, how many number of data we have taken? I think 20 pumps we have taken. 2368.17 divided by 20, you will get how much the value. So this one will be the overall average loss, not overall. It's an average loss. You will get it 2368.17 divided by 20. How much you are going to find it out? Then you will get it this much value. So this is the average loss calculation. So when you are going to take a sample. So thank you very much for watching this video. I hope you have understood what is Taguchi loss function, the fundamental of bowl curve, and what is upper specification limit, what is lower specification limit, what is meant by target value. So this information you have understood. When you are going to have one target and if there is a deviation, you are supposed to calculate what will be the Taguchi constant. After calculating the Taguchi constant, it is possible to find it out the loss, how much the loss incurred when you are going to have some statistical data. So this is what Taguchi found normally. Many of the quality explanations, so they are giving in a qualitative manner. When you are going to approach the Taguchi loss function or Taguchi's perspectives, then you can find out many things in a statistical manner. You can prove that how much the loss or how much the profit, and then how can we approach the quality. So all those information you will get it. So thank you very much, and we will see another one video.